Good evening, everybody. Hey, how you doing? It's still me. It's me. It's Mr. D with no beard. So don't think that you're seeing something else or anything else or anyone else. It's still me. And congratulations, this is my 10th broadcast. I want to get into the heart of today's lesson. This was kind of a meaty lesson. Some of the students seemed to have a little bit of difficulty understanding the whole concept and everything. But when you see how it works, you'll see how this all makes sense. So I chose a different example. I actually included a picture of the example. I did a screenshot here. So if anybody was absent today or anything like that, you can use today's example, just copy it or copy and paste and whatever, put it into your notebook, and then watch how I do it here to show you what we were doing. Now, we did the whole Chantel problem, and the students will tell you that that was a very rich problem. And then for the homework tonight, excuse me, I'm like, excuse me. For the homework tonight, they had one problem to do, only one problem. Had a lot of steps in it, but it was only one problem. So for today's example, tonight's example, I chose something different, okay? And you can find the problem in there. It's talking about, you know, cola and grams of sugar and all that. And what I'm going to do is I'm going to show you the two steps, the two key steps on how we're going to turn this ratio table into a number line, a double number line, using the information here. And I was telling the kids the real world application, let them show you in their notebook. One of the examples is that there was a babysitter. She makes $5.50 an hour. She wants to buy a dress that costs $52.25. Well, how many hours does she need to work exactly? And the kid's like, well, maybe she works 55 hours and makes a little bit extra. You could do that, but they want to know exactly how much. So I put it in perspective. Let's say that you're making plans. You need to plan out your day. How many hours do you exactly need to work? Because then it's cutoff time, and then you're gone. You're going to your movie. You're going to whatever. So basically, I was showing the kids that now you're starting to put the ratio table together with the double number line, so you can plot out how much time or how much money you would need to figure something out. Like when I used to work for Sony, I used to make $15 an hour. And I would figure out that, 1 hour was $15. 2 hours is $30. 3 hours is $45. 4 hours is $60. But a typical day is 8 hours. Why keep adding when I can then skip ahead and multiply the 4 by 2 for 8 hours? But if I'm going to multiply the 4, which is $60 by 2, I must multiply the 60 as well by 2. So in 8 hours, I'm making $120. You and I, we all do this when we're trying to calculate bills and budgets and everything. Now we're doing this into the real world. Now, if you're not doing money and stuff like that, I was telling the kids, when you take your heart rate, a lot of people, what they'll do is that they'll do it for 15 seconds. And it'll beat, let's say, 30 times in 15 seconds. Then there's 60 seconds in a minute. So you're multiplying the 15 by 4 to get the minute, and then you multiply the beats by 4 to get the total beats that you would get in a minute. So that's where we're going with this, and we're doing it in our head. That's standard algorithm. That's where we want them to go to, but we want to show them the how and the why we're doing it this way. So the first thing they said was this. The first thing they said was, okay, in the question, you have 12 ounces of cola giving you 40 grams of sugar. And they just want you to create equivalent ratios that can go in here and that can go in there. Now, the beauty of this is that you get so many students who are like very literal, and they're like, I need to know what to do. The directions say that they can create any equivalent ratio they want. So they're not wrong unless they do it wrong. But I tell them, you can choose what you want to do to make the ratio. Now, we did practice the following: scaling up and scaling down. Scaling up means you're increasing, scaling down is decreasing. And I explained it in another video. When you scale up, you're either doing it by multiplication or you're adding consistently. In this case, what we're going to do is we're going to scale up by multiplication. And I'm going to pick a random number in my head. 3. I like 3. I'm going to choose 3. So if I'm going to multiply the 12 by 3, I must multiply the 40 by 3. So that's 120 grams of sugar. Sorry, I should put my labels in there. And this is 36 ounces of soda. So you see how the ratio, and now we're getting into what are called proportions. And with the holidays coming up and people are going to be baking and cooking, well, you know, these, you know, look at, hold on, let me show you. So I show, here's an example. Here's corn. I don't know if you could see it. Wait, I know there's lights on it. Servings per container, 3.5 servings per one container. So one container will serve 3.5 servings. But if you have 7 people, you're going to need 2 of these. So it's 1 for 3.5. And then that would mean 2 for 7. And then that would mean 3 would be 10.5. But what if we wanted 30? Well, then you multiply that 3 by 10, so you get 30 of these, and you multiply its proportion by 10. But we'll get to that later. So that's 36. That's 40. That's 120. Now over here, when you downscale, it's division or subtraction. In this case, we're going to keep it easy, and we're going to do division and multiplication. Multiplication is repeated addition, and subtraction, division is just repeated subtraction. So multiplication, repeated addition, division, repeated subtraction. So that's a 12, that's a 40. They're both even numbers. I tell the kids you can do 2, but 2 means you're usually going to do more work. Let's try 4. Let's divide by 4. 4 goes into 12 3 times. So for every 3 ounces, you're going to divide by 4 here. You get 10 grams of sugar. So now we have a nice little equivalent ratio chart right here. 3 ounces to 12 ounces to 36 ounces, 12 grams to 40 grams. These are all equivalent to each other. Okay? They're all equivalent. Now, jump down to the problem. Okay, so we created equivalent ratios. We created equivalent ratios using a ratio table, and now we will represent them on what's called a double number line. The purpose of a double number line is to actually find the exact amount. So we can, you know, estimate, we can guess and all that good stuff. So let me create my double number line. Does the red show up? Yeah, red shows up. Good. All right. Now, I do put the arrows. I should make a dot. I do the arrows both ways because it means it's increasing infinitely that way. It's decreasing infinitely that way. And a few questions I'm going to ask the kiddos. What are we comparing? Now, I'm actually going to switch to green because red looks like it's not showing up. So we are comparing ounces of cola and grams of sugar. So I'm going to put the cola, and I'm going to put the sugar here. Okay, there we go. Now, the question here says 1 liter of cola is about 34 ounces. How many grams of sugar are in 1 liter? Well, let's take a look. 34 ounces. That's going to be in between here. 34. Which means down here, we're going to have an I don't know answer. Okay? So then I tell the, and this is where I lose the kids, because we got to zoom into this section here and like blow it up here. So the 34 is in between the 12 and it's in between the 36. Now it is definitely much closer to the 36, but we'll get to that in a second. The sugar, okay, so 12 is connected to 40. 36 is connected to 120. Okay? So now, this is where we start using the tape diagram and we start doing some division. You'll see. So we go here. And what I do is I'm going to do this. 36 minus 12 is 24. So that means there's 24 things here. That means I got to make 23 lines. That's a lot. That is a lot. I don't want to really do all that work. I wish there was a way maybe I could get this 12 closer to the 36. You know, there is a way. There is a way. And what I'm going to do is now, I'm going to multiply it by 2. So we did here by 3, but I'm going to see what happens if I multiply it by 2. Now, if we had an extended ratio table, we can do that. But I'm going to do it on a double number line. Times 2 gives me 24. And if I multiply this by 2, I must multiply this by 2. And now I'm going to get 80. Now, this gives me a little bit more wiggle room to work with. Okay, times 2. From here to here is 12. Now I can make more lines. But if I can find... No, we'll do that. We'll do that. So we got 12 in here. So I need 11 lines. So here we go. So basically from here to here, we're going to make a tape diagram. Actually, I need a little bit more room. So I'm going to go right up here. Like I said, I'm sorry I'm using such a small board, and I know my handwriting is choppy, but I can just do the best I can. All right, so here we go. Now, this entire thing is worth 12, because this goes from 36 to 24. So 36 minus 24 is 12. It's valued at 12. Okay? Now remember, we're trying to find the grams of sugar. So we don't know what this is, but we know that this altogether is 40. But watch. So let's do this. 11 lines. So, let me show you here. So 120 minus, okay, there we go. Minus 80 is 40. Whoa! So that means that this whole thing is worth 40. Remember, we're trying to figure out how much right about here is, which is 34, because that's what they asked for over here. And then we're trying to figure out how many grams of sugar that is. So what we're really trying to figure out is this 24, okay, to 36 is 12. So that means I got to divide this up into 12 parts, 11 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Make sure I got the parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. So basically, this is saying that 40 divided by 12 will tell me what the intervals are. It gives me the value for each one of these. Okay? So let's do that. Let's do that. So 40 divided by 12 is 3 times 12, because this is 4 tens. So 3 times 2 is 6. 3 times 1 is 3. Okay? So that's 4. Okay, put it, hold on. Yes, that's 4. We're not going to do the decimal. So that's 3 and 4 twelfths. Now, I told the kids about scaling down. So that 3 and 4 twelfths, 3 and 4 twelfths really equals 3. Well, divide them by a constant. Divide A and divide B by a constant. Let's do it by 4. Okay, 4 divided by 4 is 1. 12 divided by 4 is 3. So each one of these is 3 and 1. Oops. 3 and a third. I know I wish I had a bigger board. I'm sorry, everybody. So now we figured out that each one of these is worth 3 and a third. Okay? So 3 and a third. 3 and 1/3. I'm using the best I can. Yes, you do have to put the value in for every single piece. Okay. Okay. Now, that's going to get us up to that 40 range. So, with that being said, okay, here we go. Watch this. So 24, I need to put all those values here. 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. There's 36. So right now, this tape diagram is coming over here. So 36, 35, 34 is right here. Okay? 34. Well, how many sections is that? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections. Okay, so that means I got to add to this 80. Okay, remember this is 12 sections, so let's get rid of these. I got to add up all of these, or 10 groups of 3 1/3. Okay, so with that being said, here we go. That's 30, because 10, so here you go, 3 1/3 times 10. 10 increments to get to that 34. Okay, so I got to multiply. What I'm going to do is I'm going to separate it and use my properties of multiplication. Distributive property. 10 times 3 is 30. 10 times 1/3 is 10 thirds. But mister, that's an improper fraction. That's what we used to call it. Now they call it a fraction greater than 1. Well then, reduce it or simplify it. Now you got 10 divided by 3, right? Okay. 3 goes into it 3 times. 3 times 3 is 9. And it leaves 1/3 left over. So you add this answer to this answer. And down, so basically that is, this section here, this section from here to here is worth 33 1/3. But that's not our answer. That's the range from here to here, down here. You have to add this 33 1/3 to that one, to that 80. So now let me erase this over here. You have 80 plus 33 1/3. There's no third up here, so that comes right down. 0 and 3 is 3. 8 and 3 is 11. 113 1/3 grams of sugar. Does that work? Yeah, it's closer to 120 than it is 80. So basically, for 34 ounces of soda, you're going to get, right there, that's my weird arrow, 113 grams and a third. Now, that took about 17 minutes to do. Usually in class, we are a little bit longer. I'd stop and ask the kids, at what step, at what point did I lose you? And then or where are you confused? What don't you understand? The big thing that the children do not understand is when you see this range here and you bring it over here. And what I saw here is that 12 to 36, I'd be here forever. So let me jump ahead by multiplying it by a constant. All those lessons we did with constants, here it is. As long as I'm doing it to both, it counts. Maybe you could have skip counted, because in some of the examples, what we did where we added and then we skip count, then we multiplied. Like I said, if you work 4 hours at $15 an hour, how much are you going to work for 8? And how much are you going to make for 8 hours? Then you just add, get to that 4th hour, multiply it by 2. Okay, and then you have 8 hours. And then you and I, some of us work full time. You got to multiply that 1 day of work by 5 for a full day a week. So there you go. That's how you're creating the equivalent ratios. So I hope this example helped. You can rewind it, play it, look at the question. And if you have any questions, remember, you can always call me, 631-793-4088. Message me, text me, email me, Mr. DeRiggi, mrderiggi28@gmail.com, or eric.deriggi@imagineschools.com or .org. I don't know which one they're doing, so either one. Or you can contact me through this Facebook page. Now, I've been having some glitches with this Facebook page. I might actually turn it into a YouTube channel. It's just that I hoped to have turned this Facebook page into like a multimedia thing where we actually would put photos of the kids working and doing stuff. If you want to know what we're doing in science right now, we're talking about Newton's laws of motion and stuff. We already did law number 1 for every time an object is at rest or an object is in motion, it stays in motion, stays in rest until something acts on it. Today we did like a little prelude to law number 2. All right, and basically, long story short, was what's the difference between speed, velocity, and acceleration? Speed is constant. Acceleration is the change from one constant speed to another constant speed. So that's accelerating. And then you decelerate by going from one constant speed to another. And velocity is a change in direction. And that's like, think about when you're driving, you slow down a little bit, so you're changing direction, you're changing velocity. We're in baseball, when they throw the ball, it comes out, and then the velocity of the break in the breaking ball or a curveball. So that was the lesson in about, it says 20 minutes right now. I did it for about 18, 17 minutes. Any questions, please go ahead and ask. But if you look carefully, we'll just run over it again. Did we create equivalent ratios using a ratio table? Yes. And over here, we did it on a number line. And did we represent it on a double number line? Yes, we did. 12 to 40, 12 to 40, 36 to 120, 36 to 120. Extend the double number line to solve real world problems. That's this part right here, where the 12 to 36, it's going to be here forever. I skipped ahead by multiplying by 2. I skipped ahead by, if I multiplied here by 2, I multiplied here by 2. I got 24 to 80. And then I figured that this 24 to 36 is valued at 12 on this, okay? And then this same section is valued at 40. But this is 12 sections because we got this. And 12 sections is easier to do than 40 sections. So 40 in 12 sections, each section is worth 3 1/3. And then we figured out that, okay, well, let's divide it up into the 12 sections. And 34 is the 10th section in, so we don't need these two. 10 groups of 3 1/3. 10 groups of 3 1/3. Distributive property, 10 times 3 is 30. 10 times a third is 10 thirds. Okay, and if you remember, we did the whole ratio where A to B equals A over B, the quotient. 10 divided by 3 is 3 1/3. Okay, so it's really, this part here is worth 33 1/3. Added to this part, so we get from here to here. So this question mark is valued at 113 1/3 grams of sugar in 1 liter of soda. So think about that the next time you take the little ones to 7-Eleven or any of these places and they get that 1 liter big slam bottle. It's 113 1/3 grams of sugar. I don't know. It's just a math problem. All right. Save a pineapple. Have a great day.